Bert already mentioned a few things about our authoritative server. I'm going to go in a bit deeper, not much, but if you have any questions, just shout. As said, most people know PowerDNS as a database-driven name server. We do this. We still do this very well. There's something on the screen.
Maybe you should plug it out and plug it in again.
No.
No.
No. Fuses the computer in the big. It's gone.
Oh, all right.
It helped.
Okay, so we support a number of SQL backends: Postgres, SQLite, MySQL, the most popular ones. Oracle, if you like. The portability database Bert mentioned, Runtime, PowerDNS, and Oracle. We support OpenDBX. Has anybody heard of that? Yeah, okay. One guy. OpenDBX is a multi-backend database library developed by a German guy who I forgot the name of. It's like ODBC, but smaller. People have been using that to connect PowerDNS to MS SQL. I'm not sure why, but people seem to want this. It doesn't do DNSSEC, so we have now developed an ODBC backend, so you can connect PowerDNS to MS SQL with DNSSEC. These five, marked with a star, all go through a generic database layer that we developed, which allows all of these to be configured in the same way and allows us to have a lot less code. So just a picture to clarify things. You have the recursor sitting at your access ISP. You ask it from google.com, it goes out to the internet to ask things for you, or example.com. It talks to the authoritative. The authoritative talks to the database, does a query, gets something back, does another query. It's good to know that in many cases we cannot answer a DNS query with one database query. It may involve anywhere between 1 and 5 or 10. I think Bert might have a graph later showing this in the metronome presentation.
Yes. Oh. Now I will.
Yeah. All right. Database gives another answer and we reply the question. This is the basic flow of how the authoritative works with a database. You can customize any of the queries. If you type this command, you tell it to launch the backend you want. This is the generic SQLite 3 backend. You tell it, give me the config. You grab for one of the queries. So this is the default query that's in our code base, but you can override any of these queries for any need you have. Some people, for example, want to be able to disable domains because a customer hasn't paid. This was not a feature for us, so people would add this bit themselves. I've seen people do 3 table joins on every query to get the billing status and be able to operate based on that. And then 3 weeks later they called, why is my domain down? Why are these customers' domains down? And I said, well, the status is 2. What does that mean? I don't know what it means. You told me to break all the domains if the status was 2. So support is sometimes funny. But you can do many things you can think of this way. And if that's not good enough, we have other options. Bert also mentioned this briefly. We are data file or database compatible with some competing products. Bind, obviously. The bind zone files, the bind config. We can read those, we can serve those. We start up faster than bind, even with the text files. We support MyDNS, which is an older MySQL-based name server that I believe some hosting providers are still running. TinyDNS. Any TinyDNS users here? Ex-TinyDNS users? No? TinyDNS is a very small name server. Name says it's written by Dan Bernstein. Very fast, a bit weird to configure, but it has been very popular. So somebody in our community wrote that backend for us. He wanted something to do to learn C++ and DNS, so I gave him like 15 lines of code, the very basic start of this backend, and he wrote the whole thing for free. So we sent him beer, I think.
We should have. A quick question from the audience: is it too warm or too cold now? Close the door.
A bit cold, yeah.
A bit cold? I'll close the door for you. See, we care about our users.
Yeah, okay, so suppose you already have a bind deployment, you have your named.conf, you have some zone files, might look like this. PowerDNS will just load this file. Everything under options, except for directory, will be ignored. We take those other things from the PowerDNS config, which is confusing to some people, but we feel it gives flexibility. And of course, here below you have your zone statement. We will read that. So you can start PowerDNS, you launch the bind backend, you point it to your named config, parsing when domains will report when done, and in this case, 0 seconds later, it is done, because we only have one domain. So you can see very well how quickly it is loading your zones. If any had trouble, if any have been removed, because you can add remove zones at runtime, of course. Now, if you do that a lot, I would recommend a database. Okay, yeah, this is just showing that it works. This is the zone file we loaded. We query for a record, comes out, we do a zone transfer. We this just works with your bind file. Okay, scripting backends. We also have a separate presentation on that, if you like. Bert mentioned this briefly also. If you have dynamic needs that go beyond editing database queries, you can script in a number of languages, in a number of ways. Lua can run in process. The other languages, or any language you like, really, people have been doing shell scripting backends, can be connected to PowerDNS in a variety of ways that we can cover later, if you like. Question? No? Okay. If you have data, of course you want this data to be redundantly available. Maybe you have two machines sitting in a rack together, maybe you have data centers in 5 countries, so you need replication. Traditionally, replication happens within the DNS protocol with zone transfers. This is how bind does it, this is how all name servers do it. You can protect this with T6, so it can even be secure, but of course you have a fancy database sitting behind your PowerDNS. So PowerDNS understands that your database may be doing the replication. You can in fact decide replication on a per domain base. You can tell PowerDNS these 100 domains will be database replicated, but these other 5 will be replicated within the DNS protocol. And this allows you to take a big incoherent network of multiple DNS platforms and combine it all into PowerDNS on one server, or well, one type of server, to simplify your setup without breaking existing things. Yes?
Is it possible to do both? So internally I replicate my MySQL database, and externally I maybe would not like to replicate my MySQL database.
Yes, yes, you can mix and match in any way that you like. Oh, wow. So updating records, this is a thing that people want, apparently. I don't see the appeal. We have a REST API. We have a presentation on that, if you like. So we'll see what you want to hear in a bit. SQL, obviously, that's why most people go for PowerDNS. And recently we have implemented NS Update, also known as Dynamic DNS. For bind users, this is the normal way to update things at runtime, especially for big zones. We always had SQL and the API, so we didn't really care, but there's still some demand, so we give the users what they want. And of course, if you use bind zone files, you can use your favorite editor or an editor you hate, whatever you like. Bert mentioned this, our one-click DNSSEC. It really is that simple. I have another slide deck that admits it isn't, but for now, you configure PowerDNS, you configure your database, you go PDNSSEC secure zone, example.net. There's a default algorithm, default key size. It secures the zone, it adds some metadata to the database to be able to serve DNSSEC right. Are you done? This can be all there is to it, to sign a zone with DNSSEC in PowerDNS. You can talk to the server at runtime. You can ask for the uptime. You can twiddle a couple of flags, not all, and you could tell PowerDNS to do things like send a notification to the slaves that this domain has been updated and they should retransfer it. Of course, this also happens automatically, but people can be impatient. That was that.
Very good.
What shall we do next?
I think the recursion.
That's yours?
Can I ask a question?
Yes.
So you show us how to secure a zone with DNSSEC.
Yes.
But there's usually more to it, right? I mean, you still have to upload your DS records to the
Yes,
to the
yes.
domain.
That's the one thing we cannot do.
Do some key rollover every now and then. At least the zone signing key probably.
No.
No.
No?
Every 20 years. It's a recommendation.
20 years.
20 years.
Yeah, that's for the zone signing key, but that's for the key signing key, but the zone signing key you want to
Do you roll your SSH keys?
Huh?
Do you roll your secure shell keys?
Yeah, actually I do.
Oh,
Okay, then for you, then you are. I've always wanted to meet someone. No, so somewhere, so there is sort of a point to the rolling, but it's a very complicated discussion on why it's actually needed, because it's not like there's sort of this mental image that every time you make an RSA signature that one bit of the key leaks out. That's sort of the mental picture that people have, but it's not that way. So if you want to roll your key, we have a very easy syntax to do that for you. So it's like new key, add new key, deactivate old key, remove old key. It's very, very simple to do. It's just that it's not on most people's threat radar, because the chance that someone is actually... So the whole risk is that if you have a computer that is randomly attacking a large amount of RSA keys, it might one point get lucky. But the interesting part of that calculation is the chance that it got lucky with your key is very small. The chance that it got lucky with a key is sort of out there. So one of the protections against it is to have many zones.
And I have another question then regarding DNSSEC. So this is protecting a zone that you already have with DNSSEC, but in practice you're going to have domain names transferred from one registrar to another, and thus from one DNS operator to another. Now I know that somewhere more recently SIDN decided to implement some standard for exchanging key material between operators.
We have the guy that wrote the standard here.
Case, you stand up.
This is Case. This is.
You wrote that document.
I want to also recognize Case here. Case is one of the many PowerDNS consultants who actually wrote a fairly large bit of the DNSSEC code in PowerDNS, and he did this stuff.
Yeah,
so we have standards for it.
Of registrars, and I'm very proud of that, and chair of that association.
Very good.
But
Very good.
does PowerDNS also help in that procedure in some way, or is that something that has to be done out of band always?
I think Case can best answer this.
There is room in PowerDNS to store a DNS key record, and it's added to your DNS key set. But that's about it for PowerDNS. The rest is communication with your registrar, get the key material from your registrar via the key relay. It's a little bit complicated administrative process, and you cannot do this in PowerDNS. It's too complicated, and there are too many things you need to check before you add key material to your zone. I have to totally related.
What if both registrars were running PowerDNS?
Not simplify things.
The actual, so I like to sort of give one last answer to this question. There's a 60-page document written that outlines the risks involved in transferring a DNSSEC signed domain from one registrar to the other. And the sort of recommended procedure, if you care about your uptime, is to briefly remove DNSSEC during the move and then add it back. Or read the 60-page manual. We've tried real hard to make it possible to do it, but it's the DNSSEC standard does not quite cooperate with that. So that's one of the reasons why we were a little bit late to the DNSSEC party, because we said this stuff is too complicated. It's too complicated that you need a 60-page manual to transfer a domain name from one registrar to the other while it's still signed.
I think the 60-page manual, the process in there has been executed once
By us.
worldwide. Sorry?
It's by the PowerDNS project,
By Case, yeah.
by Case and SIDN. They made a press release out of it.
Yeah.
It sort of tells you a little bit how hard it is. But if anyone has ideas how we can further automate it, we're all ears. But it appears to be fundamentally hard.
That's just very interesting because it just makes domain portability so hard with DNSSEC unless you turn it off. Maybe that's another barrier to DNSSEC adoption.
Or it's a selling point. Yeah, because these guys are not going to move away unless they read the 60-page document. Okay, a little bit more on the PowerDNS recursor.